are from Group 1F and we will be talking about the sedimentation process in the wastewater treatment industry. Hi, I'm Tasha.
Hi, I'm Najmi.
Hi, my name is Hafizuddin.
Hi, I'm Naim.
Hi, my name is Muhammad Syarif Iqmal.
According to the Agua Clara textbook, sedimentation is a unique process where suspended flocks are settled out from the water and is driven by gravity. It is important to optimize the sedimentation process as it is useful in industries, especially in wastewater treatment industry. This experiment is divided into two parts. In part A, we want to study the optimum condition for different coagulants to achieve high removal efficiency. And number 2, we want to develop mathematical model to predict the removal efficiency of each coagulant. In part B, we want to determine the effect of the diameters of solid particles and flow rate on the removal efficiency in different types of swirl tank. China has the world's largest water consumption, followed by USA. This is supported by the fact that the customers, which are their citizens, have the need to consume clean water. China and America are two of the most populated countries in the world, so the need for clean water increases tremendously. The 2018 edition of the World Water Development Report by the United Nations stated that the global demand for water has increased at a rate of 1% each year in the past decades. This will keep on increasing significantly in the near future. It is mainly driven by the domestic and industrial demand as their demands increase much faster than agricultural demand. However, the agriculture sector will still be the largest user overall. By 2050, the global water demand for all users will increase by 30% and the total population of the world will increase to up to 10.2 billion people, which shows an increment of around 32%. Although the demand for clean water keeps on increasing, the water availability is decreasing due to the reduction in resources and also pollution. At present, Asia-Pacific is leading the global water market. This is due to the increasing need for water and water system as a result of the gush in manufacturing and constructions throughout the region and also the ever-growing population. In South America, Europe, and North America, the water market is driven by the increase in the need for bottled water and also the increasing water usage in the utility sector.
So, this is one of the example of the wastewater treatment plant. As you can see on the screen, this typical dairy wastewater treatment process flow diagram that includes bar screening, grid chamber, primary clarifier or first sedimentation tank, aeration tank, secondary clarifier or second sedimentation tank, and lastly, a contact tank. Firstly, the wastewater effluent to be treated is flow into the bar screening as a pre-treatment of the wastewater. Here, the large items from the effluents are removed to avoid damage to the facilities equipment such as pump and valve. Next, on the same stage, the effluent is flowed through a grid chamber to remove the fine grits that find its way to the wastewater. Next, the effluent is flowed into pump where it forces high pressure into the aeration tank. In the aeration tank, the biological treatment of the wastewater occurs by pumping air to encourage the conversion of ammonia into nitrate and providing oxygen for the bacteria to continue to treat and stabilize the wastewater. After that, the treated wastewater is flowed from the aeration tank to be directed into a second sedimentation tank for further treatment of the wastewater. Here, the remaining organic sediment is allowed to settle out from the treated water flow. The small solid called activated sludges is allowed to sink to the bottom of the tank, and some part of the activated sludges is returned to the aeration tank to rise the bacterial concentration and enhance the breakdown of the organic material. The activated sludges waste is channeled out to the secondary wastewater tank. And finally, the wastewater is flowed into contact chamber where chlorine is added for disinfection. Here, any bacteria left in the wastewater is killed using chlorination process. Then, the well-treated clean water is channeled out to the storage tank as a final effluent.
For part A, there are two objectives need to be achieved. The first is to study the optimum condition for different coagulants to achieve highest removal efficiency. The second objective is to develop mathematical model to predict the removal efficiency of each coagulant. For this part, the wastewater from food processing industries has been taken as the effluent wastewater. The study is conducted through the experimental study, which utilizes a laboratory scale unit fed with an industrial unit effluent to evaluate the removal efficiency of chemical oxygen demand (COD) and total suspended solids (TSS). From the experiment conducted, the optimum condition for highest removal efficiency is at pH of 8.5 for ferrum chloride and ferrum sulfate and 8 for aluminium sulfate. The settling time is 40 minutes at room temperature. From the experiment conducted, the highest removal for aluminium sulfate is 79% and for TSS is 92%. For ferric chloride, the highest removal can go up to 73% 98% for COD and 93% for TSS. And lastly, for ferrous sulfate, the highest removal can go for 79% for COD and 93% for TSS. For second objective, the mathematical models are developed with the function of chemical dose and inlet concentration. The parameters are fitted and least square method was employed in order to minimize the error between the experimental and predicted data. A total of 6 mathematical models were developed, as you can see from the slide. The value of coefficient of determination R square for each of the equation is from 0.93 to 0.99, which showed a satisfactory agreement between experimental and predicted data.
For part B, we use 4 types of swirl sedimentation tank, which are the standard swirl tank, OW, swirl tank with a directional elbow, OWK, swirl settle with a profile pipe, OWR, and the swirl tank with a directional elbow and reverse outlet, OWKR. So the objective of this part is to study the effect of diameter of solid particles and the inlet flow rate on the sedimentation removal efficiency. So based on the combined graph, it can be shown that all the graphs have the same decreasing trend. However, only OWK types with 250 micrometer diameter of solid particle has a constant trend, which is 99% of removal efficiency as the flow rate is changing. Thus, we can say that the higher the inlet flow rate, the lower the efficiency it will be. Next, we can observe the effect of size particle by comparing the two graphs. The orange graph represents the tank with 250 micrometer diameter, and the blue graph represents 125 micrometer diameter of solid particle. So based on the graph, 250 micrometer diameter of solid particle has higher efficiency. Thus, we can say that the larger the size of particle, the higher the efficiency. Besides, we also can determine the relationship between the variables where the removal efficiency is directly proportional to the diameter of the particles and inversely proportional to the inlet volumetric flow rate. And based on the result, we also can identify the best swirl sedimentation tank, where the best type is the swirl sedimentation tank with a directional elbow, or OWK, with 250 micrometer diameter of solid particle, as it has the best performance and can sustain 99% of efficiency even though we change the inlet flow rate.
For safety considerations, in this experiment there are several chemical substances that are being used. Thus, it is crucial to pay full attention while conducting the chemical substances since it is hazardous. Other than that, preventive measures such as wear safety shoes with non-skid soles, wear appropriate clothes while conducting the experiment, always run the experiment after fully understand the equipment and procedures, and ensure that all the electrical equipment is safe to be used also need to be taken while conducting the experiments so that any unwanted accidents can be avoided. As conclusion, wastewater treatment is very crucial for the world in order to help human culture continue to exist. Significantly, as the human population keep increasing, the demand for treated and clean water keep increasing over years. While for the experiments, it is important to take the preventive measures while conducting the experiment. In overall, all the objectives of this experiment are successfully achieved. So that's all from us. Thank you.